We know that the rules in a transaction are stated in any order, and GeneXus determines when each one is triggered. This is sometimes confusing for developers because they feel they're no longer in control. But this is actually an advantage. Developers should only focus on declaring the logic, and GeneXus will automatically infer where and when each rule should be triggered. To explain this topic, we'll use the invoice transaction that has a second level, flight, to represent the flights included in the invoice. We're going to focus on this transaction and on triggering its rules. Note that in the flight transaction, we've added the flight available seats attribute, which will be used to record the seats available in each flight. The number of seats available will decrease every time that an invoice is issued to a customer who has purchased a number of seats on the flight. We've added it then at this level. It'll be an inferred attribute. In the customer transaction, we've also added the customer total purchases attribute to record the total amount spent by the customer in flight ticket purchases. We also added it to our transaction as an inferred attribute. The attributes invoice total amount, flight final price, and invoice flight amount of the invoice structure have been defined as formulas. In the invoice transaction, we've defined the following rules to specify its behavior. The default rule, which initializes the invoice date attribute with today's date. The subtract rule, which decreases the number of available seats on the flight according to the number of seats purchased on the invoice. Note that it'll be decreasing a flight table attribute. Here, flight available seats is inferred. The error rule displays an error message if the flight no longer has available seats. And the add rule adds the invoice total to the total purchases made by the customer. Again, an attribute included in a table of the extended table customer. In short, we have all these rules and formulas defined in the invoice transaction. The big question is, how does GeneXus know in what order to trigger them, and when to trigger them, and when not to? Of course, first there's a natural order that corresponds to the ordering of the attributes on the screen, from top to bottom, and from left to right. A rule or formula is triggered as soon as the required information is accessed. For example, the default rule only needs the value of the today variable and to know that it's in insert mode. That's why, as soon as we open the screen in insert mode, we already see the value in the field, even though we haven't even reached it. We're barely positioned on invoice ID. Let's think about what happens with the formula of the first level. Invoice total amount, which is a sum of a second level attribute. Since the sum formula needs only the invoice flight amount attribute, it'll be triggered for the header even before the first line could be entered, giving 0. But then as we enter lines, it'll be triggered again for each one. But what happens if we access the transaction in update mode and, for example, change something in a line that doesn't modify the invoice flight amount at all? In this case, we don't have any attributes to be modified that don't modify that value, because the only two editable attributes are the line ID, which cannot be changed because it's part of the primary key, and then the invoice flight seat quantity, which does modify the value of invoice flight amount. However, imagine that there were one. For example, that it must be indicated if a passenger has diabetes, and the line in question said yes, and now we want to change it to no. Obviously, in that case, the header formula would not be recalculated. This is also obvious to GeneXus, which internally extracts the existing dependencies between places assumed by the controls on the screen, the rules and formulas to build a dependency tree, known as evaluation tree, that will determine which rules and formulas will have to be triggered again when changes are made to attributes on the screen. In this example, it'll be as shown below. For example, note what happens with the attribute invoice flight seat quantity. On it depends the update using subtract of the attribute flight available seat, on which, in turn, the triggering of the error rule depends. For this reason, the condition of the error rule must be written knowing that, because of this dependency, the subtract will always have already been executed, and that's why the condition less than 0 is placed. Remember that, as we've already studied, if there are negative entries, everything done in the tree that led to this error will be undone. At the same time, the updating of the invoice flight amount formula also depends on invoice flight seat quantity, as does that of the header, invoice total amount, on which the updating of the client's total purchases depends. We can imagine that the tree is executed in a bottom-up manner. That is to say, every time an attribute value is updated, all the rules and formulas that depend on this attribute, and that are located upwards in the tree, are executed. Let's continue with the previous example. If the number of seats in an invoice line, invoice flight seat quantity, is updated, since this attribute is part of the formula that calculates the cost of the flight, invoice flight amount, this formula will be triggered again. When it's triggered again, the formula corresponding to the total amount of the invoice, invoice total amount, will also have to be triggered again. And lastly, changing the total also implies having to trigger the rule add invoice total amount, customer total purchases, because the customer's total purchases have to be updated. In addition to triggering all the formulas and rules included in the right branch of the tree from the attribute invoice flight seat quantity, the formulas and rules included in the left branch will also be triggered. As we've seen, when the value of the invoice flight seat quantity attribute is changed, the rule subtract invoice flight seat quantity, flight available seats, that updates the number of seats available on the flight, flight available seats, will also be triggered again. Consequently, by making changes to this rule, the value of the flight available seats attribute will be evaluated to see if the error rule indicating that there aren't any more available seats should be triggered. If the condition for triggering the error is met, everything done in the tree since the change in the invoice flight seat quantity attribute will be automatically undone, and the database data will return to the state prior to the execution of the error rule. Now let's see an example in which a rule is not always triggered at the desired time. Let's suppose that immediately after invoicing a customer for a number of flight seats purchased, we want to generate a receipt for payment. If the customer is up to date with payments, then we generate a new receipt. Otherwise, we add the amount of this invoice to the previous outstanding receipt. We've created a receipt of payment transaction. It's made up of the receipt identifier, the date, the state, which is an enumerated domain with the values pending and completed, the customer, and a second level to record the invoices for which the payment receipt is issued. Then, when a new invoice is entered, the program searches if there's already a receipt from that customer in pending status. If there is one, a new line is added with this invoice. Otherwise, the header and line are created, and the header is left in pending status. Then the customer comes to pay, so the employee opens the transaction and changes the attribute receipt of payment invoice total paid for the invoices the customer wants to pay. The receipt of payment status can only be changed to completed if the values of invoice total amount and receipt of payment invoice total paid match for all lines. Let's assume that this change is made by the user, who changes the value of receipt of payment status. So, it must be confirmed that changing to completed is not allowed if there's an unpaid or incorrectly paid invoice. We could think of placing the following error rule, conditioning it to be triggered when we're updating a receipt. The status is completed, and the value of the attribute indicating what should be paid and the one indicating what has been paid for a line do not match. But when will this rule be triggered? Clearly, if we access the transaction, change the status to completed, and for a line, we enter a different value than expected, it'll be triggered. But what if we don't even access another line that has a 0 amount paid? Will the rule be triggered? The answer is no. When executing a transaction in update mode, we may not want to modify the header and change only one line. In that case, what will be triggered? The header will always be updated, and then only the modified line. For it, everything will be triggered according to the evaluation tree. How would we solve this case? One solution is to call a procedure to which we send the receipt ID. Once we've waited for all the lines to be modified, and after these modifications have been made in the database, but before the commit so we can undo them. This procedure runs through all the lines and makes sure that none are left with a different value for the attributes we're interested in. Although for the error rule, it may seem that we do not need to condition the before complete event, since the OK variable to be evaluated is already conditioned, it is actually necessary. If we didn't condition the error to exactly the same event, it would break the dependencies between both rules. Each triggering event has its own evaluation tree, which means that if we condition many rules to the same event, it'll order them at the time the event occurs according to its dependencies, as we saw before. In sum, the rules and formulas stated in a transaction are usually interrelated, and GeneXus determines the dependencies between them, as well as the order in which they're evaluated. Sometimes, the evaluation tree doesn't determine the order of execution that we want. A clear example of this is the one we just saw, where we had to delay the triggering moment of the procedure that checks the line records and the subsequent error. If you want to see in more detail the order of the evaluations triggered by GeneXus, you can use the detailed navigation list. Here's the difference between the two. Let's see, for example, that in the detailed navigation, we're shown the rules and the moments when they will be triggered, which doesn't happen in the other case. Detailed navigation can be useful in cases where we need to understand exactly where a formula or rule is being triggered. But it usually takes longer to specify, so we often don't need it. To enable it, go to the menu options, Tools, Options, and in the Build category, activate the Detailed Navigation property.